Okay, now on page 5 of probability, we are doing number 7. We are going to do A, B1, and B3. List in systematic order the 24 different orders in which 4 people A, B, C, D may sit in a row. So I am going to go copy that from the other page. Hold on a second. Okay, so now I copied the list from the other page because we did this problem before. Now we determine the probability that when 4 people sit at random in a row, A sits on the one end of the seat. So all we need to do is look for all the combinations where A is at either the left end or the right end. So here there's 6 where A is at the left end, right? What about the right end? They're not so organized. Well, there's one here, there's one here, that's 2, there's 3, there's 4, there's 5, there's 6. So there's 6 combinations where A is on the right end also. So we'll put 6, and that's divided by 24, which is the total number of combinations. So that would be 1 out of 4. What about combinations where A and B sit together? Let's count those. So here's 1, that's 2. No. So just 2 on this side. There's 1, 3. There's 1, 4. There's 1, 5, 6, 7, 8, 9, 10. So unless I counted wrong, there's 10. 10 divided by 24. You could also be written as 5/12. Okay. 22C. Two-dimensional grids can give us excellent visual displays of sample spaces. We can use them to count favorable outcomes and so calculate probabilities. This point represents a tail from point A and a tail from point B. This represents a tail from point A and a head from point B. There are 4 members of the sample space shown. Okay. Number 1, we're going to do A and C. So A, draw the grid of a sample space when a 5-cent and a 10-cent coin are tossed simultaneously, hence determine the probability of getting 2 heads. Okay, so we're going to draw the diagram, and so the x-axis is going to be 5-cent piece, y-axis is going to be the 10-cent piece, and we are going to see that there are 4 outcomes. The outcomes are 5 cents head tails, and the 10-cent head tails also. Okay? So what is the possibility of having 2 heads? Let's see. Basically 1 out of 4. What about exactly 1 head? How many possibilities are there for exactly 1 head? I would say, let's see, not that one. It would be heads tails or tails heads. And tails tails also not. So it would be 2 out of 4. Which is equal to 1/2. Alright. Number 2. A coin and a pentagonal spinner with sectors 1, 2, and 3, 4, 5 are tossed and spun respectively. Draw a grid to illustrate the sample space of possible outcomes. A coin and a pentagonal spinner with sectors 1, 2, 3, 4, 5 are tossed and spun respectively. Okay, so we're going to draw a grid, and it's going to be 5 wide and 2 long, for example. Okay, so we're going to have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. The width here is the coin. It's going to be heads or tails on the coin, and then the spinner is going to be 1, 2, 3, 4, 5, and then we'll draw the grid here. Looks kind of like that. So we have drawn the grid. Then it says how many outcomes are possible. Basically, it will be 2 times 5. That would be 10. Okay. All right, and then the next page, it continues on with C1 and C2. C1 and C3, I'm sorry. So, same problem again. Use your grid to determine the chance of getting a tail and a 3. A tail and a 3. Let's mark that. Tail and 3. So there's only one combination that satisfies that description. So out of a total of 10, it would be 1 out of 10, so it would be 1 10. What about 3? Use the grid to determine the chance of getting an odd number. So that would be, odd number would be this one or this one, this one or this one, this one or this one. So that would be 6 outcomes out of 10. So we'd say 6 out of 10. Okay. Number 3. We're going to do A, B, and I. A pair of dice is rolled. The 36 different possible results are illustrated in the two-dimensional grid. Use the grid to determine the probability of getting 2 3s. So 2 3s, that would be this one right there, right? So that would be 1 out of 36. What's the probability of getting exactly 1 6? Exactly 1 6 would be any of these, right? Not the last one because that's 2 6s, and any of these. So that would be about 5 plus 5, which would be 10 divided by 36, which you could also write as 5 divided by 18. Last of all, a sum of 7 or 11. Let's try to find those. Let's use a new color like orange. Sum of 7 or 11. So like 6 and 1, 6 and 1. 5 and 2, 5 and 2. 4 and 3, 4 and 3. So those all add up to 7. What about 11? Are there anything add up to 11? Do you know why these pairs are famous? 7 and 11? Because when you play a game called craps in a casino, if you roll 7 or 11 at certain times, it's either good or bad. And so that's why you roll it with 2 dice. And so that's why this is a famous probability. 6, 7, 8. So there's 8. There's 8 outcomes that are a sum of 7 or 11. So it would be 8 divided by 36. So that's the same as 2 divided by 9. Okay? Alright, 22D. A table of outcomes compares 2 categorical values, usually results from a survey. If this was math studies, this would be leading right to a chi-squared, but you guys don't do it. Okay, we're going to do A, C, and E. So a sample of adults in a suburb were surveyed about their current employment status and their level of education. The results are summarized in the table below. So attended university, did not attend, employed, unemployed. So basically they're saying, oh, is there a relationship between your education and whether you're unemployed or not? Estimate the probability that the next randomly chosen adult attended university. Well, here they're only interested in attended university, so we kind of need to know the totals of some of these rows and columns to figure this out. Let's use the offline calculator and total these up. So, for example, 225 plus 34 gives us 259. So these added together give us 259. What about 81 and 197? That gives us 278. What about 81 and 34? That gives us 115. And what about 225 and 197? That gives us 422. Okay. So first thing they ask us is how many, or for the next randomly chosen adult, what's the probability that he went to university? So we could take the statistics we have about students attending university for all the people we've counted up until now, and up until we've counted now, 259 have attended university. And how many total have we counted? 537. Okay, so the probability that the next person will attend university is about 259 divided by 537. What about the probability that the next person is unemployed? Well, our unemployment total is 115 divided by 537. So that would be the probability that the next person is unemployed. What about attended university given that they are unemployed? Given that they are unemployed. So the first thing we're going to do is we're only going to consider the unemployed people because they said given that the person is unemployed, we are discarding the employed people. So what's left? What is the probability that the next person went to university if we know he's unemployed? It will be 34, the number of people who attended university, divided by a total of 115 for unemployed. So that would be the fraction for E. Okay, I'm not dividing these out because it doesn't matter. You can just leave a fraction. All right, and so that is the end of page 6.